second question, find and classify all the critical points for f as a function of x comma y. 3x squared y plus y cubed minus 3x squared minus 3y squared plus 2. So the first thing we do is to find the critical points. And to do that, we need to find this one, f subscript partial differential respect to x. We need to also find partial differential respect to y. And then we equate them together. I mean, this one equal to 0. This means partial differential respect to x is 0. And what? And partial differential respect to y is 0. So we solve these two equations to get the critical point. Okay? At critical points, partial differential respect to x must be 0. Partial differential respect to y must be 0. So let's get this one. So when you are differentiating respect to x, the other variable must be constant. So you keep your y constant here, and that will give you 6xy. You are only differentiating this one, x squared, which is 2x times 3. That's 6x times y. We have this. Then come here. That's minus what? Minus 6. And we can also get the partial differential respect to y. Where do you see y? We have y here. X will be constant, so we have 3x squared. We are only differentiating y in this place. Then here also, that's our plus 3y squared. And then here we have what? Minus what? Minus 6y. So let's equate the two together. This one equal to 0. This one equal to 0. Critical points, we have this equal to 0. 6x is common. So we have this. So x is equal to 0 or y equal to what? 1. And don't forget the second one also. So when x is 0, plug into this place and get a value. So this will cancel. So we have 3y squared minus 6y equal to 0. We can factorize that 3y, and so we have y equal to what? 0 or 2. So at that point now we have 0, 0 and 0, 2. So that's the first critical points. Let's check for when y is 1. Come back to the second equation, this equation, and plug in y equal to 1. So we have plus 3 minus 6 equal to 0. So, and that will give us what? 3x squared. Plus 3 minus 6, that's minus 3. Move it to the other side. S is equal to plus or minus 1. So we can interpret the critical point. So we have when x is minus 1, in this place, y is 1. And also when x is 1, y is 1. So these are critical points. These are critical points. So let's now analyze the critical points. We want to know which one is minimum, which one is maximum. I'm going to start with this one, 0, 0. So let's substitute that. The second differential, let's get that respect to x. That will give us 6y. I'm differentiating this one respect to x minus 6. So can I get that second differential at 0, 0? That will give me minus 6. Then let's get the second differential respect to y. We've gotten the first one, this one. Do it again respect to y. So that will give us 6y minus 6. So that second differential at 0, 0, that will give me minus 6. I need one more thing again. I need the partial differential. I'm going to differentiate this one, this fourth differential, this fourth partial differential respect to y. F subscript x, y. So that will be equal to 6x. So, and at that point, that will be what? That will be 0. So I've gotten all I needed. So let's get that d at that point. So this one is what? Minus 6. This one, second differential at that point. That's minus 6 also. Then minus this one. That's also, that will be 0 squared. So I'm having 36. So this one is positive. So then, if that is the case, we need to check again this one at that 0, 0. Is it positive or negative? We have it here. It's negative. It's less 0. So that means 0, 0 is relative maximum. Okay? Let's pick another critical point. That's 0, 2. Do the same thing also. 0, 2. That will be equal to The second differential, that's minus 6. This one also is also minus 6. Then this one, we have the equation here to give us is also 0. So this is minus 6. So that's this one is also greater than 0. We have 36. Okay, it's greater than 0. Let's now check this one, f subscript xx at this point. We have minus 6, which is what? Less 0. If it's less 0, 0, 2 is a relative maximum. So let's check these 2 points also and confirm their nature. So let's check d at minus 1, 1. So this one, we substitute that y is 1, that will be 6 minus 6, that's 0. Then this one at that point, check that also. That will also be what? That will also be 0. That will be 0. Then we can also check. So that will give us a minus 6. So let's substitute those values. So that will be 0 dot 0, then minus into bracket minus 6 square. So that's what? That's lex 0. So let's check this one. That's 0, which is positive. So minus 1, 1 is a saddle point. Let's check the last one. 1, 1. So that will be 0 times f of y. That's also 0. Then minus 36. That's 6 square. So that's negative. It's giving us minus 36, which is less 0. So this point is a saddle point. So that's that on this question. Please quickly smash the watermarks on this video and hit the notification bell. Click on like button and begin to type your comments. Finally, share the links of this video on all your social media platforms. Thank you for doing that.